right, here we go. We're doing factoring review from Algebra Uno. Now, granted, I know you guys are going to tell me, I didn't read anything in Algebra 1. My teacher did it. I get it. Oh, well. But nonetheless, this is the Algebra 1 concept, okay? So, we're going to all pretend that you've heard it at some point in life. But even if you didn't, it's all good. Good. So to begin with, we're going to start with greatest common factor. And no one should tell me that they do not know what greatest common factor is. Okay. If you tell me you do not know what greatest common factor is, I'm going to blame you, not your teacher. Okay. What is the greatest common factor? What does it mean? There we go. Your greatest common factor is the largest number that divides evenly into two or more numbers, right? Now, we're also going to look at it in the algebra perspective is now that you have variables, right? So, in terms, we're looking for, these are our formal words, factoring polynomials with a common monomial factor. Monomial means that I am not adding or subtracting anything. It is just a single term expression, okay? So starting off with a problem from an ninth grade book. We have 15m squared minus 9. I'm going to ask you, what is the GCF of the two terms? What is the GCF? GCF is 3. I was waiting for more than one person to say that. So our GCF is 3. That means that 3 is the largest number that will equally divide into each term, okay? We're going to divide by the GCF. When you divide by the GCF, that is called your quotient. So we're going to divide each term by 3. Okay. The remaining value of that is going to give me 5m squared minus 3. Yes. Your factored form is written as your GCF. Yes. Oh, Carolyn, you can see over your head. Okay. All right. So GCF times your quotient. So our GCF is 3 and our quotient is 5m squared minus 3. This is our factored form. Okay. Think about factoring. When you're factoring something, you're dividing it out. You're not getting rid of it. You're just dividing it out. So like, think about an overage child that still lives at home. The parents are like, we're done. You need to move out. Okay. You still belong to your parents. You just don't live in the house with them anymore. Okay. That's what's happening when you're writing something in factored form. You still belong to the expression. You just don't live inside the parentheses. Okay. Yes. All right. Now, when there's a variable in place, such as here, 5x squared plus 10x, you are now looking at what is your lowest number of that variable they have in common, okay? So, for example, I have x squared and x to the 1. The least amount of x's they have in common is 1. So, we have 5 and 10 is going to give us 5. That's our numerical GCF. Our variable GCF is going to be just 1x. Now I'm going to divide each term by my GCF to find my quotient. I divide each term by my GCF. And what am I left with? Anybody? Somebody? Good. 1x plus 2. What happens to your x's? They cancel. They don't really cancel. It becomes Casper the Friendly Ghost, right? Because it's x to the 1, x to the 1. 1 minus 1 is 0, and anything to the 0 power is 1. Okay? Your factored form is your GCF times your quotient. So we have 5x times x plus 2. Doable? I thought so too. Your turn. Here you go. So you have 4x to the 5th minus 6x cubed plus 14x. Find your numerical and variable GCF. Why are you staring at me? If I gave you one extra term. You have one extra term. It's one extra. You got this. That was more than 20 minutes, ma'am.
That was not more than 20 minutes. That was not 20 minutes. It's been like 10 minutes.
No, it's 3:01 is when you stop.
I didn't start till like 3:45. I didn't. I didn't start till like 3. We didn't start until the tardy bell rang. Wait.
No, you started. Then that was a while ago.
Wait, what time is it right now? 3:01?
Yeah.
Yeah, the tardy bell rings at 2:40. That's exactly 20 minutes.
No, it doesn't.
Yes, it does. We leave our class at 2:35. The tardy bell. Also, a lot of noise with that one.
You chose to take it in here during that time.
But that's exactly 20 minutes. That's what I'm saying.
Put in the box.
Box.
You know where it goes.
Where's my box?
You only got one.
Are you ready? All right, what's my numerical GCF? 2. And what's my variable GCF? X. Okay, so you should have divided each factor by 2x. So when we divide each factor by 2x, we get 2x to the 4 minus plus 7. Okay, remember when you are dividing variables, you're subtracting their powers. Girls, please put it in the box and stuff. Turn it in. There's nothing else to do. I don't know, a day. Okay, so when you write it in factored form, you have 2x to the 4 minus 3x squared plus 7. Yes? All right, let's do it a bunch of variables. Okay? Okay, the new additive here is that there's a negative. When your leading term is negative, your GCF is negative. Do you hear me? Leading is negative, then therefore your GCF is negative. So in this case, our leading term is negative, so our GCF is going to be negative as well. All right, go. 90 seconds. I believe in you. Right? All right, what's my numerical GCF? -4. What are my variables? Huh? ABC squared. -8 and -12. They both are divisible by -4.
Did you say mom?
For your number? Greatest?
Oh.
your, your greatest? Least common multiple and least common is different. All right, so then once you divide, your quotient should come out to be 2a minus, or plus, I'm sorry, 3 what? 3b? So your factored form is -4a bc to the 3rd times 2a plus 3b. I don't know why it is. You just felt like funness in that moment. You like what? You like me so much? That's so great. That's what I heard. I like you too, Jess. All right, here you go. Oh, good. Are you ready? Number 5. You have 3x to the 4th minus 9x cubed y plus 6x squared y times y squared. Remember, GCF means every term has it in common. Right, right, RJ? Right? Every term has it in common. Hmm? Geniuses, you got this.
Like your confidence.
Gotta keep hope alive. All right, what's for GCF? 3x squared. What's my smallest value of x's?
What we get the square?
What's my smallest value on my x's?
Oh,
Do we see it? 3x squared is my GCF. We divide every term by 3x squared. Good job, guys. No one fell for the y. So proud of y'all. All right, so we're left with x squared minus 3xy plus 2y squared. So our factored form is 3x squared times x squared minus 3xy plus 2y squared.
wait, why does
The y's were not touched because the first term did not have a y. Make sense?
I didn't
Okay. All right. Last check. What's the GCF? What's the quotient? What is your factored form? Check with your peers if you finish before we go over it. Remember, for the variables, it's the least number power.
know why. I'm doing why.
Are you ready? What happened?
I didn't even think.
What happened? Let's do it. Let's do it. Here we go. X's. I have x cubed and x squared, which is my smallest. I have y squared and y, which is my smallest. I have z and z squared, which is my smallest. Z. My least amount of the variable, okay? Why? Don't do the class because of you. 15 divided by 5 is 3. X cubed divided by x squared is y squared divided by y. Y and z divided by z does what? Cancels. Comes a ghost. 20 divided by 5 is 4. X squared divided by x squared. Ghost. Y divided by y. Ghost. Z squared divided by z. Z. So my factored form is 5x squared yz times 3xy plus 4z. Yes? Well, it's too late. It happened. Okay? If terms have absolutely nothing in common, you write prime. Prime. If they have absolutely nothing in common, you would write it prime and call it a day. So for example, if I said to factor 3a plus 2b, what would you tell me? Prime. There's no GCF, right? That's it. Okay? All right. Now, prime. A prime is a polynomial that cannot be factored generally, right? However, there are some factors, some forms that are special. This is an example of a special form. It's called the quadratic trinomial form. Okay, why is it quadratic? This x squared makes it quadratic. Why is it a trinomial? There's three, what are those called? I've said it 100 terms. There's 3 terms, okay? So it's a quadratic trinomial because it's a quadratic by the x squared, and there are 1, 2, 3 terms, okay? In terms of quadratic, we call this our A term, this is our B term, and this is our C term. Make sense? All right. So this is for when your A term has a coefficient of 1. You're going to do what some teachers refer to as branches or mental math to factor. So what you're doing is you're undoing FOIL, essentially. Do y'all remember what FOIL is? The FOIL process, quote unquote, the algorithm. You're undoing that to figure out where did this come from, okay? You do that by first listing out the factors of your C term. This is my C term, which is 12. So the factors of 12 are 1, 12, 2, 6, 3, and 4. And you're going to ask yourself, which of these factors will add together to equal my B term? My B term is what? 7. So out of my options, which will add together to equal 7? 3 and 4. So just to check, 3 times 4 is 12. 3 plus 4 is 7. So that means that my factors are B plus 3 and B plus 4. And now I have factored what I thought was a prime. That's it. You check yourself by using FOIL. So if you weren't confident in yourself, like, oh, I don't know if I did that right, you would ask yourself, what is B times B? Your first times your first. What's B times B? B squared. Your outside times your outside. What's B times 4? 4B. Your inside, 3 times B, 3B. And your last, 3 times 4 is 12. Do I come back to where I started? So what does that tell me? I didn't mess up. I did it right. I'm a genius. Yes. So are you. Okay. Are you ready to try? Your turn. Here you go. You have t squared plus 12t plus 35. Our A term has a coefficient of 1, so we get to do mental math. What is my C? 35. So I'm asking myself, what factors of 35 add to give me 12? And they are 7 and 5. That's because 7 times 5 is 35, and 7 plus 5 is 12. So what is my factored form of t squared plus 12t plus 35? T plus 7 and t plus 5. If I didn't feel good about it, what would I need to do? It's not bad, right? I know you want it to be, but it's not. Okay? Oh no, my C is negative. What does that mean? One of my factors has to be negative. So my C is negative 24. There we go. So one of the factors has to be negative. If you are a visual person, then by all means, list out your factors and check it out. So I would be like 1 and negative 24, or negative 1 and 24, 2 and negative 12, or negative 2 and 12, 3 and negative 8, or negative 3 and 8, ... Do we get that? That's what should be rotating in your brain, okay? Out of the options I have listed, which two added together will equal 5? Negative 3 and 8, like Tasharmi said. So my factors are Z minus 3 and Z plus 8. And if I didn't feel good about it, what would I need to do? Foil and check. How do we feel about branching? Good? Do we see why it becomes mental math? Because eventually the more you do it, the quicker you kind of think about it. Yes. All right, now we're going to combine the two, GCF and branches. Okay, they come together. They come together. Are we really? I do. I agree. So first thing you're going to do is check your GCF. Is there a GCF? Yes. What's my GCF? 2. So I'm going to divide everything by 2. So we're left with 2 times x squared minus 9x plus 14. Now I'm going to ask myself, what multiplies to give me 14, but adds to give me negative 9? What kind of 7 and 2? It has to be a negative 7 and a negative 2. A negative times a negative makes a positive, but a negative plus a negative still makes a negative. How do we feel? Combining. It was all right. It was terrible, I know. The horror of it all. Your turn. Trying to figure it out. What? This class is over. We didn't even start bingo today. That's what I said. We didn't even get to start bingo.
Well, is it a negative 3 instructions?
It's positive. Is your leading negative? All right. So you should have factored out your 3. Did we factor out 3? So our GCF is 3. When we factor out 3, we're left with x squared plus 2x minus 3. So what multiplies to give me negative 3, but adds to give me positive 2? That gives me a positive 3 and a negative 1. Which way you write it? Nope, it does not. It does not. What? Okay. All right. And if I wasn't sure about myself, I could FOIL and redistribute to check myself. Does that make sense? All right. So your due now tomorrow is going to be that one coming in. But really quick, making sure we're feeling good about it. Share something with your teacher, aka me, or peer about something you feel fairly confident in doing today. Everything. We've got everything confident. quitting your job has nothing to do with what we learned today. Anyone else wants to share? What did we learn? How do you feel about it?
I like the branches.
You like the branches? Okay, you like branches? Anyone else? Audrey? You like the GCF? Okay, feel confident in GCF. Jacob, what about you? What are you feeling confident in what we did today? No?
Go through.
It wasn't a no or yes question. I said, what did you feel confident in? Pretty easy. All right.